So today we're going to be talking about multiplicity, which is the number of times a factor is repeated in a polynomial function. So in this example, both of these factors appear one time each. And it creates a root at x equals -3 and x equals 2. So the roots are here at 2 and -3. If we were to multiply out the first term of all of the leading coefficient of all of our factors of this polynomial, we would get a x squared, which has a positive 1 for its leading coefficient, and it also has a even degree. We know that the graph is going to go up on the right because it is positive, and it's going to have the same end behavior because the degree is even, and the graph will look something like this. In case you didn't have a chance to get the definition of multiplicity, I will pause here for a moment so you can pause the video and take that down. All right, now the second example here, we see there's a repeated root. Now problems like this will often look like this, indicating that the factor is repeated. So these are essentially the same thing. Both of them say that there is a root at x equals -2, but this particular one has two factors that give you the same root. The constant term doesn't actually generate a root because there's no x value you can plug into -3 to make -3 equals 0. But we have one root for this graph. Technically we have two roots, but they're repeated. So our root is at -2. If we were to multiply our leading coefficient of each of our factors, we would eventually get -3x squared, which has an even degree and a negative leading coefficient, meaning that this graph will go down on the right, and because it is even, it will go down towards -infinity on the left as well. Now, the special part about this is you'll notice that this graph kind of has to just touch this point here at -2. It has to touch it. And the reason it has to touch it is, let's say it went through this point. In order to come back down, it would eventually have to create another x-intercept, which this graph doesn't have. So it has to touch it. And it will always touch if the multiplicity, or the number of times the factor appears in a particular polynomial, is an even number. In this case, you'll notice that these are both odd. And what happens is when the multiplicity, the number of times the factor repeats, is 1, the graph will pass through the point at that value. All right, so let's take a look at another example. So here's an example. This factor has two roots, and they are both equal to 0. This factor has three roots, and they're both equal to 5. And this factor has a root at 6, and there are 6 of those. So this graph is going to have x-intercepts at 0, 5, and 6. But how will the graph look? Well, first we need to multiply out the leading coefficient of each of our factors. So this is 3x to the second times x 3 times. So that's going to be 3x to the fifth times, so that's, once again, that's 3x to the second times x times x times x because of this 3 here. So that's 3x to the fifth times x 6 more times, so that's going to be 3x to the 11th. All right, so that is our leading coefficient. It has a positive leading coefficient, so the graph will go up on the right, and because it is an odd degree, it will go down on the left. Now, the 0 has an even multiplicity because it has a exponent of 2, meaning there's two factors of x. So the graph will touch 0 but will not pass through. It'll come back down, it'll eventually turn around going towards the 5, which has an odd multiplicity, so the graph will actually pass through the 5, then it will come back down to the 6, where at this point it should become clear that because the graph has to go up, it has to touch and just turn around. So the even degrees will lead to points that are turning points, where the graph turns. There are other turning points, as you can see as well, and these turning points are known as maximums and minimums, relative maximums and minimums, meaning that in the area that they're located in, there are a highest point or a lowest point. So it doesn't need to be a x-intercept in order to be a maximum or a minimum. But the important point of today's lesson is that when you have an even multiplicity, the graph will only touch the graph at that x-intercept, whereas if it has an odd multiplicity, it will pass through. And this is, of course, when you're given graphs that are factored. If we look at our final example, this one, it makes it easier to see the leading coefficient. It's x squared, meaning it goes up on the right because we have a positive leading coefficient. The degree is even, so it will go up on the left as well. But we have to factor this to see that it actually is a representation of x plus 3 times x plus 3, or x plus 3 squared, meaning that there is a root at x equals -3. And because it is even, that means the graph will approach -3 and then go up. I probably drew this way too far away, so it would probably look more like this. And that is our graph. All right, and in class tomorrow we will complete the worksheet related to this.